So we've talked about functions, we've talked about how to evaluate functions at numbers and with variables. We've talked about how to do addition and subtraction, multiplication, division of functions, how to do function compositions. Now we're going to talk about domain and range of a function. That's something that comes up quite a bit in algebra. And what what really is being asked is for a function, if you're asked about what the domain of the function that is concerned with x or the independent variable, and basically what they're asking is what can x be? Are there any restrictions on what the value of x can be? And I'll give you an example here so you can see exactly what we're talking about. And for the range of a function, that's with y, that's the dependent variable. And you're being asked, what can y be? And that's really what is being asked when uh, you're being asked about the domain and the range of a function. So, as an example, let's suppose we have a function f of x equals 10 divided by x minus 3. Okay. And you're asked for the domain. Well, the domain deals with what the possible values of x can be. So you can see x can be any number, really, except for 3. Because if you have 3, then you have 3 minus 3 equals 0. You'll have 0 in the denominator, and that's an indeterminate number. 10 any number divided by 0 will give you an error. It's an indeterminate number. So when we're asked what the domain of x is, x cannot equal 3. Well, that's true, but that's not really how it's expressed in most problems, because for whatever reason, they don't care, they being the teachers, they don't care what x can't be, but what they're concerned is what x can be. And the way that we write that is we do that in interval notation, and we can say, well, x can be anything from negative infinity up to 3, but not including, so it's a parentheses. And the union, it can be anything from 3, but not including 3, to infinity. So that's your domain. It's x can be any number from negative infinity to 3, or from 3 to infinity. It can be, which is the same thing as saying x can't be 3, but this is the more complete answer when you're being asked what the domain of a function is. So, if you're asked what the range of the same function is, well, that has to do with y. All right? And if we've already said that the domain can be any number but 3, then what we can show for the range of this function is the range can be anything from negative infinity up to 0. Because we're never going to get to 0 here, because in order for it to be 0, this 10 would have to be 0, or this denominator would have to be 0, but we know we can't have that. So this range will never equal 0. It can give, as x would get smaller and smaller. Say x is, I don't know, x is positive 3, x is positive 2.99999. So then you'd get 10 divided by a negative 0.0001 or something to that effect. So you'd basically get a very large negative number. So that would give you the range of, that would give you, and as that gets smaller and smaller as a negative number, your y value would get to be a larger negative number. So I can go from negative infinity to 0, and the same would hold true for the other side of it. It can go from 0 to infinity. So your range of this function can be anything from negative infinity to 0, but not including 0, or it can go from 0 to infinity. Now, sometimes you'll be asked, and we'll show this on a graph here. So I went ahead and went to our graph program and entered this as this function into the graph equation. So sometimes you'll be asked as part of the problem, okay, you found the domain and range. When is the range increasing? For what values in the domain is the range increasing? And if you show it on a graph here, you can see that the range is increasing. Well, we're very close to 0 here. And then it starts increasing along here as x gets closer and closer to 3. Your y value is getting more negative. So it's decreasing from a negative infinity to 3. It's increasing in the negative direction, but that's actually decreasing because you're getting to be a larger negative number. So it's getting smaller, if that makes sense. So it's decreasing from negative infinity to 3. And then it's also decreasing from 3 to infinity, because when you're on the other side of 3, you're at a very high, your infinity, if you're close to 3 on the positive side. And then as you get closer to positive infinity on your domain, you're actually getting smaller. So it's one of those where it's decreasing, becoming more negative in both negative infinity to 3 and then from 3 to infinity. If you were asked, well, where is it increasing? Well, you're increasing when you go from infinity to 3, if that makes sense. I mean, that's one of the things that you may be asked is how the function acts as you get closer and closer to the asymptotes. And the asymptote is a line here that it's a value that the function will never reach. And in this case, you'll have an asymptote at x equals 3 because it'll never equal 3. All right, so through the magic of editing here, we're going to go on to a different function here and talk about the domain and range of these functions. So our first function we have is y equals the square root of x, x to the 1/2, minus 3. And that graph looks like this. It starts at y equals negative 3, and it goes on to infinity there. So what we're being asked is, what's the domain and range? So for the domain, we're being asked, what are the possible values of x? Well, x, since it's the square root, x cannot be less than 0. So our possible value of x ends at 0, and it goes on to infinity. So our domain would be 0 to infinity. So then our possible values of y, so for our range, being asked what are the possible values of y? Well, x can't be less than 0, so y can't be less than negative 3. And being that that's the case, our range is going to be negative 3, and then as x gets closer to infinity, Y is going to get close to infinity too, and so it's going to be, our range is going to be -3 to infinity. And I'll zoom out here, and you can see that that Y is, it's going to increase at a slow rate, but there's no asymptote here that says Y can't get bigger than a certain number. So our range is going to be our domain. Just to recap, our domain can be anything from 0 to infinity, and our range can be anything from -3 to infinity. And we're also being asked to evaluate this function at f equals 1. Well, and that's easy enough. We can do that one of two ways. We can plug it into our equation here. The square root of 1 minus 3. The square root of 1 is 1. Minus 3 is -2. And we can also, if we zoom in here, we can look at our graph and say, okay, x is equal to 1. And we'll drop down. So when x is 1, y is equal to -2. So that's the way we could do it if we're given a graph like this. We can do it one of two ways like that. So for a second function that we're given, this is a quadratic function, and we'll get into that later in a different video. As you can see, it's a parabolic facing downward, but the equation is negative x minus 1 squared plus 4. Well, what are the possible values of x for our domain? Well, there's no restriction on what x can be in either direction. X can go to negative infinity, x can go to positive infinity. So our domain is going to be anything from negative infinity to infinity. All real numbers, basically. Our range, though, is going to be anything from negative infinity to 4. And it's not going to get to be greater than 4. That's as high as it's going to go in this case. So our range is going to be negative infinity to 4. And we can just leave it up like that. We don't have to do negative infinity to 4 and the union of 4 to negative infinity. We just say negative infinity to 4. The highest this graph is going to be, the highest this function is going to be, is 4. So our domain is negative infinity to infinity, and our range is going to be negative infinity to 4. So if we were going to evaluate this function when f equals 1, we can do it again in one of two ways. We can just plug 1 in here and say 1 minus 1 is 0. Well, that's easy enough. So y equals 4. Or we can look at the graph and say, okay, here's x at 1. Y is equal to 4 when x is 1. So that's just a brief introduction on domain and range. Remember, when you're being asked what the domain is, you're being asked if there's any restrictions on what x can be. And when you're asked about the range, you're asked if there are any restrictions on what y can be. And that, a lot of times, is going to depend on your range and the value of the function. Like in this case, there's no restriction on the domain, but you are, just based on the value of the function and the equation, you are restricted in what your range can be.